Today we're going to talk about vertical motion. So it's the importance of quadratics. So what can we use quadratics for? Well, if you use the equation h equals negative 16 t squared plus vt plus s, where h is the ending height, s is the starting height, v is the velocity, and t is the time, you can use this equation for some real-life problems here. So now let's talk about velocity more specifically. Okay? If you were throwing an object and you throw it upwards, so you're going to throw it up in the air, the velocity is going to be positive. And if you throw it downward, so like off of a building or something, you throw it towards the ground, it's going to be negative. And if you just drop it, you don't actually throw it, you just release it, you drop it, the velocity starts at 0. Okay, so let's keep that in mind as we use this equation for real-life problems here. So number 1 says you jump off of a 15-foot diving board with an initial upward velocity of 3 feet per second. How long will it take you to hit the water? Okay, so we've got h equals negative 16 t squared plus vt plus s. So I just copied this equation, and I'm going to look at all of the numbers that they gave us. 15-foot diving board. That's how high you are starting. So that's going to be your starting height. Initial upward velocity of 3 feet per second. So that is v, and it's going to be positive. How long will it take you to hit the water? Well, if you hit the water, your height from the water is going to be 0. So your ending height is going to be 0. I'm going to go ahead and put some numbers in here. And what you see is that we don't know what t is, but it's saying how long will it take you. That means that you are solving for t. You don't know the time. So let's plug in. H is your ending height. That's 0. Negative 16t squared, remember we don't know t, plus 3t because our velocity is positive 3, and our starting height was 15. Okay, so this is where we're going to use our graphing calculator. So in your graphing calculator, if you go to y equals, and clear out anything you have in there, and you're going to type this equation in, the negative 16t squared plus 3t plus 15. Be sure to use the negative 16. We're going to use x, just because that's what our calculator does, squared plus 3x plus 15. And then I'm going to graph this. What you are looking for are the x-intercepts. Okay, my pen is not writing. Okay, so we are looking for the x-intercepts. Now you're going to be looking for the positive x-intercepts because you don't want negative time. So if you are taking multiple choice, you can look here, and it might be easy to find your answer just by looking at your graph. This looks like it's at about 1, but we can figure that out perfectly if we go to the calculate menu. So second, trace to get into calculate. We are going to find the 0, so select option 2. And then it's going to say left bound. So we're going to use our cursor. We're going to move it so that it is to the left of where it crosses the x-axis. So I'm trying to find this point. So as long as that blinking cursor is to the left, I can press enter. And then I'm going to use my right arrow key to move past it to the right. Press enter again. And then I'm going to guess where it crosses. I'm going to say, my cursor doesn't get very much closer than that, so I'm just going to press enter here. And it will tell me that my 0 is at 1, 0. So that means that t equals 1. Now again, I don't really care about this negative x-intercept at this time because I don't need negative time. So How long will it take you to hit the water? 1 second. After 1 second, you will hit the water. Okay, so let's look at number 2. From the top of a 40-foot cliff, you throw a stone downward. So let's kind of start circling some important stuff here. 40-foot cliff, that's your starting height. You throw a stone downward, that means your velocity is negative. And how long will it take to hit the water? Again, your ending height is 0. So if we plug in h is 0, negative 16 t squared minus 20t, because your velocity is negative and your starting height was 40, so plus 40. Okay, so you will now want to type this into your y equals and look for the x-intercept. For this particular problem, when you're looking for your x-intercept, you are going to need to use the zoom and zoom out. Otherwise, you won't be able to find the positive x-intercept. But I do want you to try this for tomorrow. Okay, number 3, a penny is dropped. That means that your initial velocity is 0 off of a 12-foot high balcony. So your starting height is 12. And how long will it take to hit the ground? Your ending height is 0. So 0 equals negative 16 t squared plus 0t. So we don't even need that because your velocity is 0. So plus 12. Okay, so go ahead and type that into your y equals and find your x-intercept. Number 4, Mr. Veldhuizen shoots a basketball. It leaves his hands 4 feet above the ground, traveling at 30 feet per second. So, starting height, 4. Velocity, 3. And you're shooting a basketball up, so the velocity is going to be positive. And then part A says, how long does it take to hit the rim that is 11 feet tall? So this is going to be your ending height. This is your h. So we've got negative 16 t squared plus 30t plus 4. That's your starting height. Now your h is 11, so this is going to equal 11. Okay, before we could put this into our y equals, we have to get it set equal to 0, so we're going to subtract 11 from both sides. We get 0 equals negative 16t squared plus 30t minus 7. Okay, we're going to type this into our graphing calculator and find the x-intercepts. Okay, I have graphed it over here on the side, and I've zoomed in so that we could get a good picture of it. Now, I've always told you to look for the positive x-intercepts. In this particular problem, there are 2 positive x-intercepts. So, that means that it's going to hit a height of 11 feet twice. Well, if you look, let's just sketch something here. If we have a person who is shooting this basketball into a basket, excuse my drawing skills here. If we start at a height of 4 feet and we shoot it up into the basket, if the basket is 11 feet tall, you could see that it's at a height of 11 feet here and here. So this is going to be your first x-intercept. This is going to be your second x-intercept. So which x-intercept do we want for when it hits the rim? This second x-intercept here. Okay, so let's look at it. If we go into our calculate menu, we're going to calculate a 0, which is option 2. I'm going to use my left and right arrow keys. I want to have my cursor to the left of my x-intercept. So this is the x-intercept I'm trying to find. I want something to the left, so I'm going to press enter. Then I'm going to move my cursor to the right. I'm going to press enter. and then I'm going to guess. I'm going to get as close as I can. Enter, and it says 1.6. So t equals 1.6. So the ball will hit the rim after 1.6 seconds. Okay, so how long is the ball in the air higher than 11 feet? So this whole time, it's higher than 11 feet. So what I want you to do is I want you to find this x-intercept on your graph, and then if you subtract the two, it'll tell you how much time the ball was actually in the air above 11 feet. So you're going to have to go into your calculate menu and find the other x-intercept first. Please try that for tomorrow.